Assalamualaikum and a very good morning to everyone. Today we will be learning about electric field, current, and also the potential difference. But first, before we diving into this chapter, we have to know what is electricity. So, what is electricity exactly? It is the flow of electrical charge or power. So, but for now, in our generation, technology and software skills are very important, especially in electronics and AI nowadays. Smartphones and other smart devices use advanced technology to work with electrical system and create smart applications. For example, one of the applications that are mainly used in Malaysia will be TNB. TNB smart meter, to be exact. It is Malaysia main electricity provider, which is TNB is a short form of Tenaga Nasional Berhad. It has introduced the smart meter that automatically measure electricity usage and send the data to TNB. So, why is it useful for us that's using TNB? It is useful because it helps people and also businesses to track their electrical usage. So, what are the key benefits of using TNB? First, we can track usage anytime and anywhere. User can check how much electricity they are using through apps or websites. Second, accurate bills. No more estimation for bills. You will get exactly how much you use your electricity. The third one will be save energy and money. By knowing which appliances uses the more power, you can actually manage how to use them wisely. So the fourth one will be faster problem detect, where TNB can find and fix power outage quickly. Finally, it is also better for the environment. Using less energy helps reduce pollution and save our resources. So, question of the day. How is an electric field created? 2. What affects the resistance of a wire? And finally, why are smart meters useful for saving electricity? We will answer this question as we go through the chapters. So, now, we're going to talk about electric fields, current, and potential difference. What is electric field? It is a region around a charged particle where other charges experience a force. So how do we find electric field? The formula for electric field will be E is equal to F over Q. So what is E? E is the electric field. Which is what we are trying to find. F is the force. And then finally, Q is the charge. So we have to remember that E is equal to F over Q, where F is the force and Q is the charge. That's how we're gonna find electric field. So what is the unit for electric field? It will be NC over C or V over M. So let's take a simple example of what exactly is electric field. We imagine two plates where one is positive and one is negative. If we place the positive plate, if we place this positive plate, charged particle, it will move toward the negative plate. But for the negative plate, it will move on the other way of the positive plate. These are the quick diagram. So that is a quick example. Okay, so how do charges respond to electric fields? On the whiteboard, there's a positive charge and there's also a negative charge. For the positive charge, it will accelerate to the field. So the diagram will be moving towards the negative one, towards the field to be exact. While the negative charges will accelerate opposite to the field. So the diagram will look like this. So this is the negative field. Every charges will try to go into the negative field, while every charges from the positive field will try to move up, away from the positive charges. So we will also look at this. So what will happen if we put two positive charges together? So it will move away instead of going towards each other. The diagram will look like something like this. Even it's going up. So it's going towards the electric field. Let's take a quick example. Let's think about thunderstorm. Thunderstorm, where the negatively charged electrons are in the clouds, are moving towards the ground, causing lightning. That is one of an easy example of it. Next one, how do we understand electric current and also potential difference? So what exactly is electric current? Electric current is the flow of electric charges in the circuit. It is similar like water flowing through the pipe. So what is the unit for electric current? Electric current unit will be a capital A, which stands for amperes. Next is the potential difference. What is potential difference? It is the push that drives charges through a circuit. It is measured in voltage, where the unit will be a capital V, which stands for voltage. Volts. So how do we measure electric current and how do we measure potential difference? There is something we call ampere meter for electric current and voltage meter. For potential difference. So let's see at a simple diagram where we have a battery and a bulb. This will be a simple diagram where the battery provides potential difference that pushes the current through the bulb, making it to light up. So, does anyone know what will happen if we increase the voltage, which is the battery? Most answer will be the light will become brighter. But we can refer to Appendix C for more details that I have provided. So, how do we connect electric current to potential difference? There is a simple relationship between voltage, current, and resistance, which we call Ohm law. So for Ohm law, the formula will be V is equal to pi R, where V is equal to voltage, which is potential difference. I is equal to ampere, which is electric current. And finally, R is equal to resistance. So the unit for resistor, which is the only one that have no unit for now, will be ohm, where the symbol will be like this. So the key relationship for this law will be the higher the voltage, it is equal to higher current, where if the resistance is constant. For example, we are given, I'll give one of the example where we were given a circuit where the battery is 12 V and the resistor is 4 ohm. So how do we find the current? From the formula that was given using the Ohm law, it is V is equal to IR. So if we make I the subject, the formula will change into I is equal to V over R, because we're moving R to the side. Now we can calculate the current. V is 12 and resistor is 4, equal to 3 ampere. So the current is 3 ampere. It's very simple. Now, moving on to the next topic. So what are the key takeaway for the previous lesson that I just taught? First, electric fields exert forces on charges. Second one, charges particle move according to the electric field direction, which is the positive and negative. Third, current is flow of charge driven by potential difference. Finally, what we just learned is Ohm law, where it connects voltage, amperes, and resistance. Now, let's move on to series and parallel circuits. To compare two types of circuits, first, we'll be looking into series circuits. Series diagram will look like series circuit will look like this. It have one whole line to themselves basically. So this one, we have the resistor, we have the light bulb, we have the switch as usual, and battery. So how exactly are we gonna calculate series? But first, the key point for series is current flow through all of the component in where is one way basically. So now back to the formula. It is how to find total resistance. Where R1 plus R2 plus R3 plus so on. We calculate it based on how many resistors we have there. Example of a problem, for example, we have R1 is equal to 2 ohm. R2 is equal to 3 ohm. And R3 is equal to 5 ohm. Find the total. Total resistor is equal to quotient. Following the formula, we just add all of them. So, the total resistor will be 2 plus 3 plus 5 will be 10 ohm. Next, moving on to, this is series, by the way, series. there are difference between series and parallel, but it is more it is more it is more obvious when you see the diagram, basically. Now moving on to parallel. Okay, next one is parallel. So the diagram will be a battery as usual. Let's make a resistor here. And another resistor here. And then a light bulb. So as what I said before, series and parallel are more obvious, the difference, when you see the diagram. Where parallel, it have level, kind of, in a way. Basically, there's two paths. Path 1 and path 2. Where resistor only have one path. So, there's no second path. It have the same voltage going across the component, but different resistors, of course. So what is the formula to find the total resistance? For parallel, it will be 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So let's solve an example. So we have R1 as 6 ohm and we have R2 as 3 ohm. Find the total. We're trying to figure out what is the total. So the solution will be following the formula. 1 over R1 is 6 plus 1 over 3 is equal to 2. This is the total. Moving on to the next one. What can influence the resistance? So the key factor will be, the first one is the length. Moving on. Now let's talk about resistance. What exactly are resistance? Resistance is the opposition to the flow of electric current. So, the unit for resistance will be ohm. The symbol for the unit will be like this. So, how about the symbol for in a diagram? Most resistance will look like this. or it can also look like this. Now, what are the key concepts for resistance? We already learned about Ohm law, so the resistance concept will be the Ohm law itself, which is V is equal to IR. Next, moving on, how do we know ohmic and non-ohmic conductors? So, I have provided a short video for ohmic and non-ohmic conductor, which I will provide the QR code here. Now, for a quick summary, after watching the video, ohmic conductor are voltage and current increased together like metal wires. For non-ohmic conductors, there is no direct relationship like bulbs and diodes. So the key points, key factors. First one will be the length, where if the length is longer wire is equal to more resistance. Second one will be the material. Where copper have lower resistance than iron. Next one will be the temperature. Where the higher the temperature is equal to the higher the resistance. Which is in most cases, of course. And finally is the thickness. Where the thicker the wire, the less resistance it has. So these are the 4 key factors that can affect the resistance. For example, a long, thin wire has more resistance than a short, thick wire, which is long is equal to more resistance with thin wire, where thick wire have less resistance. Next will be resistivity and its application. So, how do we measure resistivity? Where basically how well a material can resist the current. So, the formula for resistivity will be R is equal to P is equal to R times A over L. So, what what exactly is this alphabets stand for? P is equal to resistivity. R is equal to resistance. L is equal to line. And finally, A is equal to cross sectional area. So for some real life example, it will be power cables where it have lower resistivity for efficiency, and electric heaters where it have high resistivity to produce heat. So for homework, find an example of resistivity in daily life and explain it in the next class, where I have provided in Appendix F for more details. Now, let's try to answer some questions together using Mentimeter. First question. How is an electric field created? Second will be, what affects the resistance of a wire? And the third one, why are smart meters useful for managing electricity? Alright, I guess that's all. Great job for today. We have covered electric fields, current, voltage, and resistance. Next class, we might look deeper into how we can control electricity efficiently in circuits. That's all from me.